Good morning. So, in the last class, I have completed the support reactions. Yes or no? So, today I will be taking up a new topic under module 3, that is analysis of simple trusses. Analysis of simple trusses. So, it is the second topic under module 3. Okay. So, first I want you people to understand, okay, what do you mean by a simple truss? Or else instead I will be calling it as steel truss. I think that would be better. So, whenever I consider an industrial shed or industrial building, instead of calling it as industrial building, let me call it as industrial shed. I think you people know that. So, in majority of the industrial shed, so the top portion, that is the roof portion, is made out of this steel truss. Okay. So, now let me define it like this. A steel truss is a structural member which is provided for the purpose of roof over which the sheets are placed. Okay. Steel truss is a structural member used for the purpose of roof, okay, over which the sheets are placed. Okay. Now, we are having different types of steel trusses. Okay. Let me move on with the different types of steel trusses. So, next heading. So, okay. So, next one is different types of steel trusses. Different types of steel trusses. So, there are various steel trusses. Okay. Let me name some of them. So, the first one is king post steel truss. King post steel truss. And let me write the diagram also. So, based on the alignment of the different members, okay, in the steel truss, so it has been named as king post steel truss, queen post steel truss, like that. So, let me draw the diagram of a king post steel truss. So, the diagram will be like this and one. So, now king post steel truss. I think you people might have seen this kind of a structure, especially at the top of a building or industrial shed. So, usually what happens, two supports will be there, and this king post steel truss will be provided usually for a span of 6 to 9 meter. So, usually for a span of 6 to 9 meter. So, there is one more type of king post steel truss. So, that can also be written as, I can say that this is a simple king post steel truss. Okay. It is a simple one. And this kind can be provided whenever the span is 4 meter to 6 meter. 4 meter to 6 meter. Now, I want you people to understand one thing. Okay. So, wherever observe here, wherever the members are meeting, this we call it as members. Observe this and this. Don't consider this entire thing as a single member. Where one more member is coming and joining with that, you need to consider this as one member, this as another member. Okay. So, this and this. Totally how many members are there? 1, 2, 3, 4, 5 members are there. Okay. Next, how many joints are there? So, we call this as the joints. We call this as the joints. I will be calling this as joint. So, 1 joint, 2 joint, 3 and 4th one. So, totally there are 4 joints and how many members? 5 members. So, this is about the king post steel truss. Now, I will be moving on with the simple fink steel truss. Second one. Simple fink steel truss. Simple Fink steel truss. There are many, out of which I will be mentioning only few. Okay, so it will be like this. So this one is a simple Fink steel truss, and usually that will be provided for a span of 6 to 9 meter. 6 meter to 9 meter. Okay, so let me rub this. I will be rubbing this portion. Okay. Now let me move on with the next kind of a steel truss, that is Howe steel truss. Third one, it's Howe steel truss. It's Howe steel truss. So it will be like this. So here also we will be having the support, here also we will be having the supports. Okay, so now so this is a Howe steel truss. So usually this will be used for a span of 9 meter to 12 meter. 9 meter to 12 meter. So next, let me move on with the next one. It is North Light steel truss. Fourth one, North Light steel truss. Okay, there are many other kinds of steel truss, only few I am mentioning. I think you people might have seen this kind of trusses in and around. Okay, so this also provided for a span ranging between 9 meter to 12 meter. Okay, this is called as the North Light steel truss. Now we'll move on with bowstring steel truss. Okay, now we'll move on with bowstring steel truss. So bowstring steel truss. Fifth one, it's bowstring steel truss. It's bowstring steel truss. Okay, so the diagram will be like this. Nowadays this is a trend, because by giving the circular, semicircular shape for the steel truss, the aesthetical appearance will be good. So now, so here at the center we will be having like this. Now so this kind of a steel truss is provided when the span is ranging between 20 meter to 30 meter. So these are all some of the different types of steel trusses. There are many other, okay, so out of which I have taken only few. Okay, so now, so I will be explaining few theory points here. The above figure shows the different steel roof trusses which are provided as a supporting for roof of different span. Okay, next, these steel roof trusses need to be analyzed and designed for self weight and wind load, because on that steel truss no one will be going and standing. Okay, so it should bear its self weight and it should bear its wind load. Okay, so that's why concentrate on this. So the steel trusses are provided. Okay, if we want to provide, we need to design it for the self weight as well as for the wind load. Okay, so next we'll move on with the next topic. So that is rules for finding zero force member. So next heading, let me rub this. So next topic is rules for finding zero force member. So what do you mean by this? I think, as I have already told you people, that there are different types of steel trusses. So let me take an example. Okay, let me consider this one. Okay, now please remember, on each member different forces will be acting. On each member different forces will be acting. Okay, I want to calculate what is the force that is acting on each member. There is a shortcut to find the zero member force, where on that particular member there won't be any force acting. So the force acting will be zero. So how to calculate that particular member? Okay, so now observe here, there are 3 points. First one, okay, so whenever you are having 3 members at a joint, this is a joint, so this is one member, this is one more member, and this is one more member. Okay, so whenever you are having 3 members at a joint and 2 forces are collinear means along a straight line. Okay, here the 2 members are collinear, yes or no? Then the third member will be 0. Please remember, whenever 3 forces are acting at a joint and the 2 forces are collinear, then the third force will be 0. Okay, let me give one more diagram to that. This is a straight line. Let me think that it is in an inclined manner. Obviously this is a joint, so these 2 members are collinear. Obviously the third member will be 0. There is nothing mandatory that the bottom line needs to be straight. So, or if it is in an inclined manner and a force is moving like this, okay, these 2 are collinear, therefore the third force will be 0. This is the first point I want you people to remember to find the zero member force. Okay, the second point, whenever there are only 2 forces acting at a joint, whenever there are only 2 members acting at a joint, okay, and no external loads are applied on that particular joint. So no external loads are applied, only 2 members are there at a particular joint, then both the members are zero member force. It means that no forces will be acting on it. Or there is one more diagram for that. So let me think that if the members are like this and this is the joint. So at a joint we are having 2 members and no external loads are applied on it. So now I can say that this is a zero member force. While doing the problem, I will be explaining how to calculate all these things. Next, there is one more, the third one. Whenever there are 2 members acting at a joint, okay, and a force is acting, an external force is acting along a particular member, okay, a force is acting along a particular member, then the other member will be a zero force member. So in which direction the external force is acting? So forget about that particular member, the other member will be a zero force member. Or I can write one more diagram to it. So observe, if it is like this, an external force is acting in this direction. If an external force is acting in one particular member direction and this is a joint, okay, the other member will be the zero force member. The other member will be the zero force member. Okay, so now I will be moving on with the assumptions made in the analysis of simple trusses. So that is an important question. So frequently that question will be asked in the examination. Okay. So now let me go with the assumptions made in the analysis of simple trusses. Okay, there are 5 assumptions that are made in the analysis of simple truss. The first one is all members have negligible weight. So all members' weight are negligible. We need to assume it. Okay, for the easiness of the design, for the easiness to design the structure, so we need to assume all members have negligible weight. Okay, all members have uniform cross section. So I think you people know that there are many members which are interconnected to form a steel truss. Yes or no? So we'll assume that the cross section of all the members are uniform. Okay, next, the members are connected at the joint through pin connections. I think you people know that there will be 2 particular connections. One is the welded connections and one more is the bolted connection. While doing so, we need to provide it as a pin. Okay, so that is the thing that we need to assume so that there won't be any friction. So it is frictionless. Next, couple moments which produces bending do not act on members of trusses. I think as you people can see here, so the members are closely provided. Okay, so what happens? So as they are closely provided, I can't expect the bending. Okay, so that is the meaning of it. Next, all members have only axial force. Whenever there is no bending, so obviously there will be axial force. Axial force means either it will be tensile, that is the stretching force, or it will be the compressive force. Okay, so these are the 5 points that I want you people to remember. That is the assumptions made in the analysis of simple truss. So assumption made in the analysis of simple truss. Now let me rub this. There is one more topic, that is methods for the analysis of simple truss. Methods for the analysis of simple truss. Methods for the analysis of simple truss. Okay. So now there are 2 methods for the analysis of simple truss. One is the method of joints, the second one is the method of section. Okay, let me take up the method of joints. Okay, it's a procedure. There are 2 methods to find the member forces in a simple truss. As you people know that there are many members. So if I want to know what is the force acting on it, so there are 2 methods. One is the method of joints and one more is method of section. First let me take up the method of joints. Okay, let me explain you the procedure. So what I need to do, the first step is, okay, so we need to calculate the support reactions by applying equations of equilibrium for the complete truss. Let me consider this as a truss. I need to calculate, obviously there will be supports. I need to calculate the support reactions for the entire truss using the equations of equilibrium. So what are all the different types of equations of equilibrium? One is sigma h is equal to 0, one more is sigma v is equal to 0 and one more is sigma m is equal to 0. Okay, that is the first step. Second step is check for zero member forces by inspection method. Check for zero force member by inspection method. I have already told you people how to do or how to check the zero member forces. There are 3 points. Okay, so already I have explained it. So we'll use that. Okay, third one, what we need to do here is, so we need to take a free body diagram at a particular joint. We need to write the free body diagram at a particular joint such that there should be at most 2 unknowns, maximum 2 unknowns should be there. Okay, such a joint we need to take and we need to write the free body diagram. Okay, and one more thing is, so whenever you are considering a joint, let me think that you are considering this particular joint and there are only two unknowns. That unknowns, initially you need to take it as tensile. After solving it, if you get your answer as positive, our assumption is right. If the value is negative, our assumption is wrong. It need not to be tension, it needs to be the compressive. That we need to mention there. Okay, so 3 steps over. 4th step, after writing the free body diagram, what I need to do? So I need to apply the equations of equilibrium for a particular joint. So as I am considering a joint, all the forces are passing through the joints. When all the forces are passing through the joint, I need not apply moment equilibrium, equations of equilibrium. So I will be applying sigma h is equal to 0 and sigma v is equal to 0. Only 2, not the moment. Okay, so 4 points over. 5th point, continue taking the free body diagram of different joints such that the forces in all the members are found out. Such that the forces in all the members are found out. Okay, these are the 5 steps that we need to follow. Okay, to analyze a simple truss. Okay, so next one is method of section. So for that also we are having a procedure. So what I will be doing is, first let me take up the problems on method of joints. So soon after completing that particular problem, I will be taking up method of section. So now let me take up the numerical problems on method of joints. So problems on method of joints. 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 Let me directly take up a problem. First one. Okay, determine the forces in all the members of truss. Determine the forces. Determine the forces in all the members of truss. Members of truss. All the members of truss shown in figure. Shown in figure. Also indicate the magnitude and nature of forces on the diagram. Also indicate magnitude and nature. Magnitude and nature of forces on the diagram. Nature of forces on diagram. On diagram. Full stop. All members are inclined at. All members are inclined at 60 degree to the horizontal. At 60 degree to the horizontal. 60 degree to the horizontal. And length of each member is 2 meter. And length of each member is 2 meter. So this is the question that they have asked. So determine the forces in all the members of the truss shown in figure. Also indicate the magnitude and nature of forces. Nature means either tensile or compressive. Magnitude means the value. Okay, our forces on diagram, all members are inclined at 60 degree to the horizontal and length of each member is 2 meter. Okay, so the diagram that they have given is like this. So the diagram that they have given, it is like this. So here they have given hinge support, and at this particular junction they have given the roller support. Okay, so now they have given this as A, this as B, this as C, this as D, this as E, where these are the joints. Okay, so now at this particular junction they have given 60 kilonewton force acting in downward direction. At this particular junction a 40 kilonewton load is acting. At C we have a 50 kilonewton force acting. 50 kilonewton force acting. So as in the question itself they have told that every member is 2 meter in length. Every member is 2 meter in length. Every member is 2 meter in length. Okay, that's it. Okay, so now what I will be doing is, first, what is the first step in the procedure? Find the support reactions using equations of equilibrium. Okay, for the complete truss. Support reactions I need to calculate. So first let me go near the supports. There are two supports. One is at A and one more is at D. So at A it's a hinged support. So as it is a hinged support, so I can expect two values. So one is in the vertical direction, I will be calling it as RA, and one more is in the horizontal direction, I will be calling it as HA. Okay, so now at the D support it's a roller. So I will be going with only one reaction, that too in the vertical direction, RD. Now I will be going with the equations of equilibrium. Now I will be going with the equations of equilibrium. So now observe here what I will be doing. So using equation of equilibrium, so what is the first one? Sigma H is equal to 0, that is rightward direction positive. So in the entire diagram I want you people to tell me, observe here, there is only one horizontal force acting, and that too it is HA, which is acting in rightward direction. So as it is only one force, HA will be equal to 0. Let me go with the second one. Sigma V is equal to 0, upward direction positive. Okay, so now RA, it is acting in upward direction, so let me take it as positive. RD also it is acting in upward direction, that also will take it as positive. So RA plus RD. Next, which are the other forces that are acting in downward direction? 40, 50, 60. So all the forces are acting in downward direction. So minus 40, minus 50, minus 60. So is equal to 0. So finally can I say RA plus RD is equal to, if I transfer it towards that side, it is 150. So let me call that as equation 1. Now I need to take moment about certain point, and clockwise direction it will be positive. Yes or no? Sir, you told that there won't be any couple moment acting. Yes, I am calculating the support reaction, not the member forces. Okay, so as I am calculating the support reaction, here one support reaction, here one support reaction. So the forces are acting at different points. So I need to take the moment. So now let me take the moment about A point. Obviously about these two supports I need to take either at A or at D. So I already told you people, where there are maximum number of forces, take about that point. So I will be taking about A point. Okay, I will be taking the moment about A point. So let me take moment about A point. So now, so there is a force 60 kilonewton. Yes or no? So the force is acting in vertical direction. I want moment about this point. Let me extend a line of action in vertical direction. So don't you think that this force needs to go and touch it in clockwise direction? So it is 60 into 2. So it is 60 into 2. Next, there is one more RD which is acting in upward direction. Don't you think that this needs to go and touch it in anti-clockwise direction? So minus RD into 4. Minus RD into 4. Next, there are two more. Now the thing is, observe, they have given, so the angle between the two members which is inclined with horizontal is 60 degree. So this is also 60 degree, this is also 60 degree, everywhere it is 60 degree. With horizontal, wherever we are having a member, so the angle made by the other member with horizontal is 60 degree, they have only given. So don't you think that this is also 60, this is also 60, obviously what will be this? So this will also be 60. Yes or no? The reason is, so sum of the interior angle of a triangle should be 180 degree. So don't you think that it's an equilateral triangle? Here also it's saying it's an equilateral triangle. So whenever you drop a perpendicular from an equilateral triangle, so don't you think that it divides the entire base into two equal parts? Here also the same thing. It divides the entire base into two equal parts. So now let me go with the moment calculation. I want moment about A. So there is a 40 kilonewton force acting in downward direction. So this force needs to go and touch it in clockwise direction because the force is acting in vertical direction. I want moment about this point. Extend the line of action along the direction of the force. This force needs to go and touch it in clockwise direction. So plus 40 into 1. So plus 40 into 1. Similarly, we are having one more. So this 50 kilonewton, this also needs to go and touch it in clockwise direction. So 50 into 3 plus 50 into 3, which is equal to 0. Finally, if I solve this, I will be getting the value of RD. So after solving it in the calculator, the value that we are getting here for RD is 77.5 kilonewton. 77.5 kilonewton. Okay, I got the value. Now, I am still in need of RA. Let me substitute RD in 1. So, from 1. Okay, so RA I need to calculate. RD value, just now we have calculated it, is equal to 150. So, then RA value will be, so 72.5, I guess, yes, it's 72.5. It's 72.5 kilonewton. So now, what was the first step in the procedure? Find the support reaction using the equations of equilibrium for the complete truss. Yes, we have used the equations of equilibrium and we have found out the support reactions. So how many support reactions were there? HA, RA, RD. All the three we have calculated. So the second step is, so by inspection method, check for zero member forces. Okay. Now what I will be doing is, I will be avoiding that particular step. Okay. Zero member force. If you do it also no problem, but in this problem, not in this problem, in all the problems I will be avoiding the check for inspection for zero member forces. So then what is the third step? So take the free body diagram at a joint. So the joint should have at most 2 unknowns. Okay. So that procedure I will be continuing it in the next class. So for this class I will be stopping here. So we'll wind up. Thank you.